Okay, number 19. Y equals x, y equals 0, y equals 4, and y, oops, not y, but x equals 5. So we are finding the volume of the solid, and we're going about the line x equals 5. All right, so first let's get a handle on what this looks like. It seems that we're going to only be in the first quadrant, so that's all I'm going to draw. Y equals x is our nice diagonal. Y equals 0 is the x-axis, and then we've got y equals 4. Oh, this is exciting. So y equals 4. And then x equals 5. So this is going to intersect at 4. This is complicated. And then x equals 5 is a vertical right over here. And again, we were dealing with the, what I didn't draw in was the x-axis. So it looks like we're dealing with this region here. Be careful because you may, like this looks like a cute little region as well, but we need it to be y equals x, which is the red, y equals 0, which is the x-axis, y equals 4, which is the blue, and x equals 5, which is the green. So that's the region that we want. So we're going around x equals 5, and since this is a vertical axis of revolution, we're going to go like this. We've got horizontal rectangles, and we're going to integrate everything with respect to y. So here from A to B are y values, so we're going from 0 up to 4. Big R is the distance from the far end of the rectangle to the axis of revolution. So that distance will be the whole distance minus the red, which is, it's y equals x, but we went in terms of y. Okay, then minus little r squared. Little r is going to be 0 because our rectangle is right up against the axis of revolution. All right, so I am simplifying this so that I don't have that 0 there. 5 minus y squared dy. And then that goes into our calculator. And we should get, it looks like 124 pi over 3. Okay, that was 19. 21 gives us a parabola and a vertical line. Okay, so x equals y squared is like this. X equals 4 looks like that. And what are they saying about our region? We're going about the line, about the line x equals 5 again. Okay, that's x equals 5. This is what we're going around. So here's our region. I'm going to draw our rectangle. It's going to be perpendicular to the axis of revolution. So for this, everything is going to be in terms of y. And so what we need are these y values here. So when x is 4, y would have to be positive 2 or negative 2. So that's what we're going to do, negative 2 to 2. Big R is the distance from the axis of revolution to the far end of the rectangle. So it's going to be green minus our red. So our green is 5 minus the parabola, but we need to change that. No, we don't need to change that. It's 5 minus y squared, minus little r, which is just going to be 5 minus 4 dy. dy. So I'm going to simplify this. This is just 1. And we're going to put that in our calculator, and we should get 832 pi over 15. 33 brings us a little bit of trig. Okay, so we've got sine from x equals 0 to x equals pi. So that's going to be just half of a cycle. So our sine curve starts at the origin, half a cycle. That's pi. Let's see. And they tell us about the x-axis. All right, perfect. Okay, so what we're going to do is draw our rectangle perpendicular to the axis of revolution. This is with respect to x. We've got 0 to pi of big R is axis of revolution to the far end of the rectangle. That's going to be sine squared minus little r, which here is 0. So it's pi, 0 to pi of sine squared x. And that turns out to be, if we get it exactly, to be pi squared over 2, or to 3 decimal places would be 4.935. 35. We've got an exponential function. Okay, still about the x-axis, but we've got this y equals e to the x minus 1. So we're looking at this function between x equals 1 and x equals 2. I'm just going to find those function values. F of 1 is going to be 1, and then f of 2 is going to be e. So we're increasing because e is around 2.7. And I'm going to curve it because it's exponential. And that's our region, about the x-axis. Rectangles perpendicular to the axis of revolution. Big R, little r, pi, 1 to 2 of e to the x minus 1 squared dx, and little r is again, whoops, 0. I don't want that dx in there yet. So 1 to 2 of e to the x minus 1 squared dx. And with this, I'm just going to go straight to our decimal answer of 10. I guess this is approximately 10.036.